Hey everyone, thank you for watching. This video, we're going to be looking at getting started using natural language processing for social media data. We're going to take a look at some common data sources, data types, different approaches you could take, and different models that are available right now. So really, the most important thing about data science and really all machine learning and natural language processing in general is all about the data. So getting this data usually is the crux of your project, usually one of the most important steps. And I think it's pretty interesting. I think there's kind of like more or less two different sort of social media platforms in the way that they handle how others users can get their data. There's sort of these platforms that are designed as being public, and by default, they're more publicly facing. This is things like Reddit and Twitter and Stack Exchange and TikTok. And so there are ways, easier ways to get data for these sorts of platforms. But other sort of platforms, which are kind of based on friend structure or based on having to log in to be able to view users' profiles, these tend to be more guarded with their data. And so it's harder to get data from places like Instagram and Facebook, and they just kind of undeveloped their API for Instagram, making it a lot harder for people to get Instagram data. And LinkedIn data, you have to go through a lot of hurdles. You essentially have to log in. We're going to go a little bit more into doing that later. But it's important when you first get started to kind of think about what social media you're doing and really how easy it is for you to get your data. So public data, the first sort of data sets that we were talking about Reddit and Twitter, these are actually pretty nice and not too difficult to get a lot of data from. So they usually have official APIs, like Twitter had the Tweepy official APIs, and there's also some unofficial APIs that you can use, like Get Old Tweets, which is a pretty good program widely used in social media and health research. There's also unofficial APIs for TikTok, and similarly to Reddit, there's official and unofficial APIs. This PushShift.io is a great site if you're interested in getting a lot of Reddit data. I definitely recommend. I would highly ask that you would consider donating to the guy that's working on this. He's done a lot of work, spent a lot of his time and his own money to host a lot of this data. So if you end up using a lot of that data, be sure to consider that and how you might contribute in the future. So when you talk about more about private data, it's usually going to be a lot more difficult for you. So if a lot of these ones, like LinkedIn, they require you to log in. And so if you're using Python, you can use a program called Selenium. And essentially the idea is you're essentially making some sort of web developed application in your Python script. So that in the Python script, it'll fill out the username and the password, and you'll press the login button in your Python script again. And this will allow you to kind of get past that. That needing to kind of log in, or if this is the same thing if you need to like press a button. It's pretty much if you need to interact with JavaScript, and it'll become clear if you really try to look more into getting these data. Selenium is a good resource to that. But it is really hard to get a large amount of this. So the reason that these are kind of more private and that they require all these things is because it actually is kind of difficult. They don't really want you getting the data anyway. So they'd be ready to get kicked off. They're going to recognize your IP. It's going to be a harder time. So I definitely recommend if you aren't really interested in specific social media platforms, definitely start with one that tends to be more forward facing. It'll just make your life a lot easier in doing any analysis later on. So now I'm just going to briefly talk about a lot of the different sort of types of data that you'll get in social media analysis. And I think the most obvious ones that probably you might be thinking of right now, things like text, images, and videos. And these are kind of really the most amount of data of these sort of nature that we've ever gotten in our history. We've never had a time where we've had as much text or how much images or how many videos that have been created by just random people. And so that's a really interesting problem. But in addition to that, we also have a lot of other different kinds of information. We get location information, sometimes latitude, longitude location, things like Yelp reviews for different businesses have different, obviously, latitude and longitude for those businesses. Things like geotags, where users can actually post their specific location. We have other kind of meta elements like likes and subscribes, which can really help out a poor grad student trying to teach machine learning videos on YouTube. So if you're definitely learning anything from this, please hit me with that subscribe, hit me with that like, would really appreciate it. But really, you can also use these sort of things. There's other people that have used these sort of things to actually learn, tangible models and how certain user likes may actually be influenced by their behavior or their health. And so these will also be information. I actually did publish a paper about how information for comments specifically would be helpful. So not only what the user actually creates, and I'll have the link in that below, but and also what the user's friends would actually say, that this can also be informative of what that user is thinking in that behavior. And finally, there's also some other studies that really focus on the sort of friend structure, the sort of social aspect of social media. So in addition to just not only just this text and image and video, there's a lot of other really meta elements that are there's a lot of interesting work being done on a lot of these. So just keep that in mind. It's not just strictly limited to when we're going to be talking about text in the future for the rest of this video, but there's a lot of other sort of information, not even just besides images and video, but a lot of other meta information that's been pretty important as well. So keep that in mind. So next we're going to talk about really kind of common data formats. So if you're going to be looking at working with social media data or downloading social media data, you're probably going to be asked to probably deal with at least one of these two. The first one is this JSON, this is JavaScript object notation. And so basically it's used for whenever you call, so the Twitter API and the Reddit API, I believe both use this. And so we're actually going to give an example in Yelp in a second for in both R and Python. But basically it's this idea that you have, so every post has an object. So like this would be an example of like a JSON call. This is just kind of a dummy call. So you have some object, JSON object X, which is all of the text that you would have for your big data set. You would say, let's look at the first text, which would just be the first element, and then you would say, like, I want to look at the post field. And you could also replace this with, I want to look at the image field and see what the image points to. So every data source has its own, and so we're going to go a little bit more into that in a second. But also just keep in mind that there could also be CSVs, and I did also go over using CSVs and pandas in Python in a previous video, which you can find here. So definitely check out that one if you haven't already been familiar with CSVs. But we're going to talk a little bit more JSON files now. So we're going to talk about how to just import some data into Python using a JSON file from the Yelp academic research dataset attached in the description below. So we just need to first import this package called JSON, and then we can just, so this file is a little interesting because it's a list of JSON, of individual JSON files. Sometimes it might be like this, but you essentially have to keep an eye out on what your actual data set is and maybe just play around with it for a while. So we're going to open this data set in read mode, and then we can say that we want to make another, we can say JSON data equals some empty list. And then we can say just append JSON data with JSON loads. So this will actually turn a JSON object essentially into a Python dictionary. Because if you think about what a JSON object really just is essentially a dictionary, a Python dictionary. And so we're going to have, and it can be subset field. So we're going to say the line here. So that'll take a second to load. But once that's ready, we'll be able to return it. And so now we have each of these businesses, these Yelp businesses. It's a list of these businesses. So let's say we want the 33rd one. 33, and so then this is essentially just a dictionary if we want to say what state it was in. And so this is actually how a lot of social media data will appear if you try to get it from the internet. It'll appear essentially like this dictionary. So these JSON loads file and JSON and Python will help you actually be able to parse this data pretty easily. So now I'm going to talk just a little bit more about actually designing your experiment, really thinking about your experiment in the way that social media data is structured. And I think that there's kind of like really two different ways, and there's really a bunch of different ways you can look at it, but there's two very kind of prominent ways. I think this is the way that a lot of people choose to think about social media data is you can understand the social media data as a collection of users who post certain things. And so you can kind of treat your object, your in label on this idea of users, or you could treat your kind of grouping on the label of the individual post. And I think this is really important to keep in mind for when you're defining your algorithm, especially if you're doing any kind of neural network or deep learning algorithm. You really need to understand, what is my label on my post, or is it on post, or is it on my user? For example, if a bunch of users fill out a survey and you get their Instagram profiles, it's not necessarily true that every single post on that would correspond to that survey reference. Like, let's say it was talking about alcohol consumption or something. Not every single post would talk about alcohol, but something you might expect is that on average there might be more alcohol-related posts in the user group versus the control group for if they had different alcohol responses. And so this idea is we really want to be careful about how you're choosing to define the label, and with that'll define your individual, your question, and really is the entire experiment. So I think this is a really important concept. And so usually it's like kind of easier to get a larger number of posts, of individual posts, because you can just kind of query a bunch of posts and then kind of label them. But this is like everything is a trade-off, because similarly to how, some users might not post every single thing about alcohol, some users might not post anything about alcohol, but still choose to consume alcohol and responding to that way in a survey, for instance. So you just really need to be careful on, what you're calling, what you're going to choose to call your individual unit, whether that's the user or the individual level. And so this idea is that, as you might imagine, users create individual levels posts, and some user might have 1,000 posts, and some user might only have 1 or 2 posts. And so figuring out ways to kind of combine those is actually pretty difficult. And so just in my experiences, I honestly haven't done too much work on specifically combining individual level users into individual level posts into user level posts. But concatenation, I've heard of the concatenation of text, and from my limited experience, it does kind of work really well. But the issue is if you're doing like a neural network, you have to kind of define the size of your space first, or the size of your how much a post is, and so you're kind of limited by that. You can't just put all of the users posts in there, and then again you still have the problem of if somebody posts a lot and then somebody else doesn't a lot, and then you ask the question of if that actual act of posting is related to your outcome. And so you can see how it gets really complicated. It's if you can figure out a way to just streamline your process and just streamline your experiment, think about it in way of either user level to user level label, or starting with individual posts going to an individual label. It'll help you clean your data a lot. And so this really just depends on your field and your outcome and what you're digging, and just really have to think carefully about this. Other way I've heard is you can do things like if you have images, you can do random crops. You can also just like have text and just randomly concatenate text, and maybe you can average the results from individuals. And these are kind of just ideas. I actually haven't tried a lot of these. I know concatenation works at least somewhat well. But it's an interesting field, so actually there's a lot of places to explore, but hopefully these are just some of the ideas that I've thought about in specifically trying to tackle this problem. So the next thing you want to think about when you're doing this sort of natural language processing is really think about kind of like what everybody else has done in the field, but also what you are specifically interested in doing, what kind of data you have, and kind of where you are, what your background is, and how you're interested in really looking at this problem. And so the first sort of realm of sort of approaches is this idea of using statistics or prior knowledge approaches in order to find this better outcome. And so these are things like using word counts and frequencies, and also this sort of a dictionary approach. And so this is the idea that each word that you would have in some dictionary would be correspond to some score. They do things for like happiness. We're going to go a little bit more in a second. So you have different scores for each of these words, and these are really better for if you were trying to do some kind of psychological analysis for which there's a good dictionary for what you're trying to do, or if you're trying to have some sort of more interpretability in your argument. And the other sort of way that you can look at this is using this as like a machine learning or data-driven problem. And so if you want to do things with it like classification, neural networks, or you could use like LDA as an unsupervised topic clustering. Both of these we're going to go over in a second, but these are better for a lot more of larger data. And so I will also make the caveat that both these are mostly studied in the realm of English. I might do a video on kind of multilingual processing later, but for right now I'm mostly focusing on English as for these methods, because that's really where all these methods have been applied and researched most on. So just to briefly talk about when I'm talking about word frequency methods, so they've done things basically like you calculate the amount of the word counts, and I'm not putting formulas up here for a reason because there's multiple different ways you can kind of calculate frequency. You can calculate it as if I see one word at all, you count it as a 1. It doesn't matter if I see a million of them, it's still just a presence or absence model basically, or you could actually do word count. But there's another idea that I think you should kind of recognize if you're interested in sort of doing something like this. Might actually be a really easy way to get pretty good models, would be using just this TF IDF was what it's called. So the idea is essentially you're penalizing the prevalence in all of the other documents relative to, and then you also have a multiplication factor by the term frequency argument. So the pretty much idea is you're weighing how often something appears in your document that you're interested in, the single document, versus how often that word appears in all of the other documents. So if a term appears highly in your document, but it's very uncommon in all the other documents, it would put a large importance on that term, relative as if there was a lot in that word in your select document, but there was also a lot of that word in all of the other documents as well, then it wouldn't give you as much because that inverse document frequency wouldn't be as high. Or the term would be lower, so it would multiply, so the overall term would be lower. And so you can actually just combine these pretty straightforward using any kind of sort of classification approach for whatever kind of classification you're interested in, logistic regression, SVM, or random forest. And so I'm also going to talk about another method you can actually apply those methods, so simple classification methods using these scalar numbers. So this is this way to turn your words into numbers. I'm going to introduce some of these dictionary-based approaches. And so I'm going to first start off by saying that if you're anything like me, and I have this kind of strong analytical background and kind of a data scientist, and so when I first started working on this sort of thing, I thought the neural network was always going to be better, and that this AI approaches. But I think that like ever since I actually started working with these methods, these dictionary approaches can be very, very powerful and can outperform any neural network if you have a good dictionary for your problem. So if you can manage to find a dictionary that works really well for what you're trying to do, it ends up working out really well, and I would highly suggest you just kind of look towards that. And there's other sorts of dictionaries like SNOMED for some medical ontology dictionaries and things like that. So there's a lot of these sort of approaches that you can find mappings of concept of words to concepts essentially, and then they have different scores. And so right now I'm gonna go a little bit more into this linguistic inquiry of word counts, and so we'll go ahead and take a look at that right now. So this website is from this linguistic inquiry of word count dictionary, and I'm just basically showing because they have a nice little demonstration which we kind of use to demonstrate all dictionaries. And so you can actually just go to this website and give it a try, kind of see what it would be for your own text. So one of the things that obviously is really interesting is you can kind of indicate to the model that it is social media data. And this is actually, some of these dictionaries will let you say, it will have certain rankings or differences for social media data. And so if I say hello, thanks for subscribing because you really got a lot out of this video and you decided to subscribe. So I just wanted to, and you said that, I said this to you, so let's analyze this. And so you can kind of see that the way that this LIWC works is it kind of aggregates these, has how many I words. And so these psychologists, these brilliant people, have spent a lot of time looking at different words and kind of understanding how different words. So this is just a subset. They say you have 90 output dimensions. I actually got to update my slides because I only said 70. But I have seen this used a lot. And I think if you're doing something in psychology and you're really interested in kind of emotive processes, I'm not a psychologist, but I think there's a lot. I would highly recommend you looking into this as one method, but there's also other dictionary methods, and they all kind of work, again, more or less the same. And so we take each word and we have some summary, and they have summary variables, and so again, if you can find a really good dictionary, it actually makes your problem very easy. So there's a couple other dictionaries that you can look at. This effective norms for English words, this language assessment by medical Turks. You can see the different ones here, and I highly suggest you just look around. There might be something that works out really well for the problem that you're interested in. So next we're actually going to talk about neural networks. And so to actually run a neural network, and I'm not talking about autoencoders. If you know what that is, we'll talk about that later. If you don't know what that is, don't worry about it now. We'll talk about it later in a different video. So basically the idea is when we want a neural network though, we need to have a well-defined outcome of interest at the same level of the input. So when you're thinking about social media data, you need to have this outcome of interest that's defined on whatever you're intending to call an input. So in other words, if you're intending to input an individual post to the model, you need to have a label at the end of the day. It's an individual label. Again, we did talk about you could concatenate individual posts together to try to get a random label, randomly do it, and then average or something like that. But it would behoove you to have a really simple model to just have something the same level as the input, and at the end of the day, you need to figure out some way to really justify why you can go from the way that the input is to the way that you're trying to call your output. And the other thing you need is actually a large amount of data. And so if you try to ask me a number, I honestly can't give you. It really depends on exactly how easy your problem is. If you have a very, very easy, simple problem, you might only need 1,000 inputs, whether that's individual posts or users. If you're doing something really complicated, maybe even 10,000 isn't enough. And so really it just depends on your concept. I would definitely, if you have around at least 1,000, either individual posts or 1,000 users or 1,000 objects that you can train on, then I would, I would recommend at least trying a neural network, because it might do something interesting, and as well as if you have this well-defined outcome of interest. So there's actually a lot of different ways to look at neural network data and neural networks with natural language processing. I'm just going to briefly go over LSTM, and this is not going to be the actual video where I actually in-depth go over it. It's just I'm using this video as just an introduction to your application. There's other attention-based methods like BERT, which actually end up being really well. I'd recommend LSTM is a good first one to try because it won't take forever to train, essentially. It'll still take a long time, but not nearly as long as BERT, especially if you haven't done that much natural language processing. I think it's a good one to get started with. So wait, stop. If you don't have that much data and you really want to do a neural network and you're sad because I just told you that you need a lot of data, there's actually ways you can increase the data size. And so one way, which is really kind of popular and really helpful, is called Semi-Supervised Learning. And so the essential idea is you would label the small amount. So let's say you would go through 1,000 or so individual posts, label them all, and then what you could do is just gather a large amount of larger data. And then you essentially train a model on the small amount that you labeled, and you predict the results on the bigger model, and you use those as your actual labels. So the idea is, like, let's say we have this data set. I labeled some of these as purple and some of these as orange. And then so I can train a model essentially to differentiate purple and orange. And then I can apply it to the rest of the data to actually get a full bigger data set, just so you can actually do neural networks. So I'm just going to briefly talk about word vector embeddings. This is not going to be the video that I go really in depth to it. You can find that here if I've done it already. But the idea is essentially how we had before. When we had the dictionary, we had some score, and that was the way you can average those scores or something, but that was the way that we went from the sentence to actual numbers. And the way that these neural networks do it, or at least the LSTM and not the BERT, we'll talk about that in a different video, but the way that LSTMs and some other neural networks actually see these word data is they actually map these words into vectors, and these are called word vectors. And so this idea is that you can represent a word essentially based on its context. And so you can have some vector that represents what kind of words are neighboring to that. And then what you do is essentially when you do an LSTM, which is a long short-term memory neural network, you're essentially feeding in each word one at a time, and you're feeding in it as this time series. So you feed in these vectors, and then it figures out what the meaning was based on the time series of those vectors, essentially. And so you can actually train these vectors, these vector representations of words. You can pre-train them, and so I highly recommend if you do any sort of look at any tutorials on LSTM, they might tell you to use a different word embedding dictionary if you're not doing social media research. If you are doing social media research, I think a great embedding dictionary start is actually this Twitter Glove word embedding dictionary, which is trained on 2 billion tweets. I'll have that in the link description below, but I definitely think that that's probably the best one that you should start at. But there might be other ones. There's an advantage of training on other kinds of data too. So just be mindful. I think that what I'm really trying to communicate here is that the idea is you want to try to find vectors that are as good, that you think are good for the task. So it's very similar to the dictionary in that sense. And you want to find a dictionary that relates to your task of interest. You also want to find word vectors that are based on your task of interest. And there's different, I'm sure there's, I know there's like medicine-based word vectors, and there's financial-based word vectors. So there's a lot of different domains for each of your different fields. For Twitter, I highly recommend, again, using this one. We'll have in the link in the description below. And so finally, just wrap up talking about word vectors. I just have a quick little demonstration, just a little illustration really. But you can see like the difference between slow and slower and short and shorter. It's this idea that essentially these word vectors retain sort of similar relationships. And so again, I'm going to go into another video, but just keep in mind that these word vectors are how we kind of translate words to numbers for these neural networks. So finally, I'm going to talk about a machine learning method that you might be interested in that doesn't necessarily require labels. And so it's this idea of Latent Dirchlet Allocation, or LDA. And so basically it's this idea that you just take a large amount of documents and it kind of figures out what sort of topics are given in the documents, and it bases these topics based on words. And so this is an example from one of the papers that they started, and you see that they trained on a bunch of news articles. And so this idea is that they had these are in quotes up here, these different titles, because they're in quotes because the model doesn't actually give you these titles. The model just says that it gives you this set of words from the new film, show, music, movie, play. It gives you another set that says that's different from the set that says million tax program budget, billion federal. And so you can kind of think about how it kind of just essentially unsupervisedly takes out words and kind of figures out how words cluster together, and sort of lets you uncover it in your data, again, without labels, which is I think the cool part. So if you don't have any labels, but you are interested in doing a little bit of data exploration, LDA will help you get some of the clusters that might be in your data set. And so I think the last thing is really important to keep in mind: social media anonymity and privacy. So you really should never share any kind of social media post. So this is why I'm not uploading any data sets for you to play with. It's really it's kind of a lot of different websites don't want you to do that either, and it's just kind of being respectful and trying to really keep that in mind where we are, and obviously everything you should do should be an end user towards the privacy. Thank you so much for watching. If you don't mind, you can hit that like, hit that subscribe button if you learned anything. If you didn't learn anything, please hit that dislike. Really appreciate hearing any feedback. Thank you so much. Have a good day. Bye.